Hello and welcome. This is Jim Coppin with Rankin Technical College. In this video, we're going to look at working with functions, data types, and operators in JavaScript. So one thing actually I do want to kind of mention, obviously it might be kind of obvious here, but some of these guides, they're, kind of really had to scroll down for everything. Trying to create these a little differently so you can actually click on these and go to the different sections. I know it's probably kind of obvious seeing the buttons here, but just kind of want to let you know that. So let's start talking about functions. Functions let you package logic into reusable blocks. Data types determine what kind of information a variable can hold. Operators combine values into new results. Together, these three concepts form the working vocabulary you will use in nearly every JavaScript program you write. So working with functions, defining a function. A function is a collection of statements that share a common purpose or that calculate a return a value. Functions let you write a block of logic once and reuse it anywhere in your program. The statements that make up a function are enclosed in curly braces, forming what is known as a command block. So basically, you start out the traditional way to use the word function at the beginning. Then obviously this is a function name you're going to be giving it. You can pass in different data as parameters, right? And then basically you're going to be using, these are the statements that make up your function. And obviously within here, you'd also be accessing those parameters, right? No reason to have them if you're not going to be using them for something. So a named function. So a named function is assigned an identifier so that it can be referenced and called elsewhere in the program. A parameter is a variable listed in the function definition that receives a value when the function is called. Functions can be defined with 0, 1, or multiple parameters. Here's an example of a function called greetCustomer. You're passing in a value, a variable that's defined somewhere else, right? You're passing that in, and in this case, the customer name. Here you're doing a document.write. And as kind of we talked about in the previous guide in chapter 1, the document, right? When you see document, that's the document object model, right? And there that has a write thing that you can use, a write functionality that you can use to put things on the screen, right? And then here you've got a welcome. You're basically your static content. You're using the plus sign to concatenate. That's why you have to, if you want it to look nice, sometimes you have to put these little spaces. That's why you got a space right here to separate the comma and the customer name. But here's the concatenate operator, right? So whenever you're concatenating strings together, whenever you're using a plus sign with strings, you're using concatenation, right? Or if even one of them is a string, right? If this would have been a number 5 and a string 5, then you add those together, you're going to be doing concatenation instead of adding, right? In this case, you've got strings. Here's your static string that you're creating. Here's your variable that's being put in, and that could have a different value depending on what the customer name was set prior to calling the greetCustomer function here, okay? Then at the end, you're concatenating another string, which is an exclamation point. Anonymous functions. So an anonymous function is a function defined without a name. Because it has no identifier, it can be called by the name elsewhere in the program. Anonymous functions are typically defined at the exact place they are needed, such as directly inside an event handler or an argument to another function. Okay. So here's an anonymous function assigned to a variable. So here's a variable called square number, right? And you use the function and then the value being passed in, right? And then and in this case, you're just taking the value and multiplying it by itself, right? So use a name function when the same logic needs to be called from multiple places. Okay? Use an anonymous function for one-time tasks tied to a single event or single call. Okay? Calling a function. To call a function means to execute it using an expression containing the function's name followed by the parentheses. Any values placed inside the parentheses are called arguments, sometimes called actual parameters, right? Sending these values to a function's parameters is known as passing arguments, right? So in this case here, you've got a function called calculate area, passing in, right? Passing in a width and a height, and here you're just multiplying them together. When calling this function, right, you use the name of the function and pass in the parameters, right? Passing into two arguments, right? Passing in two arguments. It's the right way to say it. Sometimes people flip-flop those arguments, parameters, this, that, but it's really more accurate. You're passing in arguments, right? These are the arguments. These are the parameters that are being passed in, right? So these are the parameters, width and height. These are the arguments that you're passing in. Here, what you're doing is, what you do is when you call this function, whatever the result of this function, store this in a variable called room area. Returning a value from a function. So a return statement. So in this case, you got a return statement. A return statement sends a value back to whatever expression called the function. Once a return statement executes, the function stops running immediately. Any code after it inside that same function is never reached. Right? So sometimes you might have some if and else statements. Anytime you have a return, though, when you have a return and it reaches that block of code and it returns, anything after that is discarded, right? Kind of important. So once a return statement executes, the function stops running immediately. Any code after it inside that function is never reached. A function can contain multiple return statements as long as only one of them executes per call, often inside different branches of a conditional structure. And that's kind of like we're talking about, like if-else statements and other kind of conditions, right? But if-else statements, you can have if-else, multiple, each have a return value, right? Once that return executes, that's done, right? You return from that function and you're finished. Here's an example of having a function called classify temperature. It takes a parameter of degrees F, right? And down here, you've got a call to classify temperature, passing in the argument 72, right? Passing argument 72, and whatever the value of that, you're placing into the variable result. In this case, you've got multiple returns, right? You've got an if degrees is greater than or equal to 90, return hot. If degrees is less than 60, less than or equal to, I might not have said that correctly at the beginning the first time. So if this is greater than or equal to 90, return hot. If degrees is greater than or equal to 60, mild, right? Here, return cold, right? So here is kind of like your default one, right? This is basically here. This is not wrapped in an if-else, right? So basically, when this thing executes, this is just it's going to test this, and does this evaluate to true? Anything within here, right, is going to evaluate either true or false. So first, it's going to read that. Then, if it evaluates to true, it's going to return hot, and it's done. Right? If it doesn't, it's going to go to the next if. It's going to evaluate this. Okay? And then if this evaluates to true, it's going to return mild. Okay? Then it's just going to fall down here. If this didn't execute, right? If this didn't execute or this didn't execute, it's just going to fall down to this and do. You're not even testing for this. This is basically your default. If it falls through to this, if nothing else meets the requirement, right? If nothing else evaluates to true, it's going to return that. Okay. One thing you got to be careful about here, easy things to make a mistake, is you don't want to have this one before this 90-degree one, right? Because if this one's first, if it's 90 degrees, it's going to, it could be 105. It's still going to return mild if this one was first, right? So in this case, order is important, right? You need to test for this one before you test for this one, right? Because if you test for this one, anything above 60 is going to be, it's always going to return mild. It's never going to return hot if you have these flipped. All right. So a function without a return statement still completes successfully, but the expression that called it receives undefined. So some functions return values, other functions do not. In this case, this function returns something, right? So then this variable result is always going to be populated with one of these values, hot, mild, or cold. If some functions just go do something, they don't return a value, right? Some functions you just say change color and pass in a color, changes it. You don't return it, it just does it, right? And then so that isn't going to return anything. And then if you actually ended up accidentally having a variable there, and if you didn't have a return, it's just going to be undefined, right? That's the base case of, by default, it's undefined, right? So only include a return statement when a function is meant to produce a usable value. Otherwise, it's always going to be undefined, right? Managing events with functions. So event handlers as HTML attributes. The simplest way to tie a function to an event is an event handler attribute directly on an HTML element. This approach is easy to read, but it has drawbacks. It mixes the JavaScript logic into the HTML file, making the page harder to maintain as the project grows. So this is very easy to put this in here, right? But you're always having to add these things, right? And then sometimes things change, and then, well, this ain't going to quite work. I'm going to have to add another function here after this, or, you might have to do a lot of things. This can get kind of messy after a little bit. You might have to do multiple things here on clicking this and that. And so it can get kind of messy. So events as object properties, okay? A function can also be attached to an event by assigning it directly to a property of a page object in JavaScript code, rather than in the HTML markup. This keeps logic out of the HTML, but has two limitations. You cannot pass custom parameter values to a function this way. And only one function can be assigned to a given event property at a time, all right? Such as assigning a second function overwrites the first, okay? So here is the syntax, event as an object property. Here's your object reference, .onEvent, and then the name of your function, okay? So here is a show confirmation, okay? Just as an alert. So no parentheses after the function name. Since we are assigning it, here it's saying. So over here, you have no parentheses after the function name. Usually when you're passing in a value like that, okay? But since we're assigning a reference to a function, not calling it, right? So here, we're just saying document.getElementID.submit, and on click of this submit button, we want to execute this function called show confirmation, okay? Event listeners. An event listener is a method that listens for an event as it travels through the page and runs a function when that event occurs. Unlike the previous two approaches, a single object can have multiple listeners attached to the same event, and each listener can be added or removed independently. And the event model, capture and bubbling phases. JavaScript's event model describes how an event travels through the page into two phases. Right? Capture phase. An event travels from the most general object, the browser window, down through the page structure to the most specific element involved. For example, the exact button that was clicked. Right? The bubbling phase. The event then travels back up from the specific element through its containing elements, ending again at the browser window. An event listener can be configured to respond during either the capture phase or the bubbling phase. Most listeners use the bubbling phase, which is the default. Okay. So here, this method takes three parameters. The event name, right, that's a string without the on prefix, okay? The function to run, and an optional Boolean indicating whether to use the capture phase, okay? Or the bubbling phase, right? Either true or false. So this is reading this in. So this is going to come in either true or false. This is going to be the name of the function, okay? So here is kind of an example of this, okay? So what we're doing is we're saying document get element by ID order row, okay? Could be some different things. It's not really telling you what order row is here, but let's just say order rows, a div tag, maybe even a table row, whatever, right? Order row, maybe a table row, okay? And you can add an event listener to that, right? Then you basically say, let's add an event listener, click, all right? You don't include the on, right? On click, right? On mouse over, on mouse out. You skip the on, right? So here you're saying on click, okay, of this order row, call the function highlight row, okay? And then we've got that other one, the use capture, right? Whether to use the use capture, either true or false. In this case, we're saying false. The bubbling phase false is the default. So we're saying false on that, okay? So when you execute this line of code, right, doesn't mean it's going to call this when you execute this line of code. It's registering this event. It's registering an on-click event to this element, okay? And it's saying, hey, when you click, right, when it gets clicked, run this function. But when this gets executed just itself, this statement, it's just registering this event. It's putting this event on there, okay? And now it's registered. And it's just waiting. And then if this gets clicked, then it's going to go ahead and execute this, okay? Events and anonymous functions. An anonymous function can be defined directly inside an event handler attribute or inside the add event listener. This is useful when you need to pass specific argument values to a named function in response to an event. Since assigning the name function directly, as shown above, right, as shown above here, does not allow custom arguments. Okay. So here we have an anonymous function that wraps a name function. Okay. Here's a name function, right? Reset form that wraps a name function in response to an event, since assigning the name function directly, as shown above, does not allow custom arguments. So here, you're fine. You don't have a custom argument. You're not trying to pass anything in. You're good to go, right? Well, but what if you've got something you need to pass into a function, right? Here you've got a function defined as reset form, and you're passing in order form, right? You're passing something in, so you cannot do it. You cannot do it quite like this. You have to define it like this as an anonymous function, okay? Applying functions to the page load event. A common pattern is attaching a setup function to the page's load event so that form defaults, initial values, or other listeners are configured as soon as the page is ready. Okay. So this is using your window object, right? You're adding an event listener to your window object, and basically on load, you want to initialize this form. Okay. Once again, you don't use the on of the load, you just use the word load, right? So Windows has an on load event, right? And in this case, you're using initialize form, running this just like that. Using built-in JavaScript functions. JavaScript provides many built-in functions that perform common tasks without requiring you to write logic yourself. These functions are called the same way you call any function you define, by name followed by parentheses containing any required arguments. Okay, so a bunch of the different built-in functions. You can convert a string to an integer, right? This is one, parse it, converts a string to an integer. Parse float converts a string to a floating point number, right? So here's examples. These are all built-in functions that are available to use. You don't write these. You don't have to write. You don't create these yourself. They're all available, right? Parse it, taking that string 42 to the number 42. Here, parsing a float, right? Like pi, 3.14, etc., right? Is not a number, right? Test whether a value is not a number. Obviously, you're not going to do this quite like this because you already know ABC is a number or not a number, right? So, but showing you an example. Obviously, usually is not a number, something you're going to be checking that maybe where would you use that? Let's just say you've got a form and somebody enters a value or enters something somewhere on a page, or you're doing some calculation or, any kind of thing, any kind of user input. You kind of want to say, was this a number? Is this a string? You might be testing things like that, right? In this case, you're testing, is ABC a number, right? Is not a number, and that's true, right? Is not a number. Sometimes that can be confusing, and then you can do the opposite of that, which using the exclamation point, you can kind of get things a little confusing sometimes. But is not a number, that's true. The ABC is not a number. String converts a value to a string. You can just drop a number right in there, and you've now got a string. Always remember, anything you enter on a page, on like a web page, it always is going to be, I want to be careful stating this, but for the most part, they're always going to be string values. That's all it's sent, strings back and forth, right? Unless you're sending some binary type stuff, right? But for the most part, anything coming from that thing is going to be a string. Any of your input fields are always strings, right? You have to convert them if you want to use them. So maybe if somebody's entering a date, say 2026, right? In this case, you're converting it to a string, but you may want to do the other, which is a number. So somebody has a number 2026, you want to convert that to a number. That's how you convert something to a number, right? Also, I'm sure a lot of you have all seen this before. Anybody who's used the internet, sometimes you see like other kinds of characters up in the URL. And then because a lot of times certain things, like let's say you've got a space, especially, and we learned this already early on in the HTML book about get and a post, right, for like forms and stuff, and gets when you do a get, it'll put it up here in the URL, right? Post does not. But if you ever pass, let's say you got a search bar and you put a value in the search bar, well, you put a space in there. Well, they don't know what to do with that space. So what do you have to do a lot of times? In this case, that's what that's actually shown right here. You've got a space between A and B, right? So what it's going to do, it's going to convert that to %20. So %20 is basically encodes a special character for use in a URL. Okay, so a space is %20, right? So that way, when you're sending that, maybe you got your own search engine, right? You create your own search engine, and so you've got a search engine. When somebody puts a value in the search, hits search, right? Then it's going to go ahead and encode this so that when it goes to the back end, it can maintain that spacing, right? Because it can be relevant and important, right? So built-in functions belong to JavaScript itself and are available everywhere. No setup required. Yep, you don't have to include them. They're always available, right? This differs from methods which belong to a specific object and are called using dot notation, right? Such as document.write. Okay. Understanding variable scope. We talked about this a little bit already, but we're going to go into this a little more here. Scope refers to where in a program a variable or function can be referenced. JavaScript recognizes several layers of scope, determined largely by which keyword was used to declare the variable. Block scope and function scope. Variables declared with let or const inside a command block, and basically that's any code between a pair of curly braces, such as an if statement or a loop, etc., are considered block scoped. They exist only within the block and any code nested inside it. Variables declared with var are not block scoped. Instead, they, along with let and const variables declared directly inside the function body, but outside any inner block, right, have function scope. They exist anywhere within the enclosing function, right? So we'll learn about that here a little bit. Let's see, what's this? I gotta review this a little bit. Okay, good. So local scope versus global scope. Local scope is the collective term for block scope and function scope. A local variable can only be referenced within the block or function where it was declared. Global scope applies to a variable declared outside of any function or block. A global variable is accessible from anywhere in the program, right? So here's your global scope. Basically, a variable declared here outside of any function is visible. Oh, you probably can't see. I don't know if you can see that in the window there. So any variable declared here outside the function is visible everywhere in the program, right? Function scope. A variable declared here or with a var anywhere in the function is visible through the entire function, right? Block scope. A variable declared with a let or const is visible only inside this block, right? So when you define a let or const within this block, right, it's only going to be available there, right? Now it's a little different. The global scope stuff, you can define things at the global scope, right? And the whole thing is why we always say use let or const. Yes, you can define those at your global scope, but a lot of times you want to control that because you might want to, things could have the same name. You could be using multiple different JavaScript files, and if things are always global, you can have some problems. You can have some duplicate names and stuff. And that's why it always suggests to create distinctive, like unique distinctive, unique variable names, right? Instead of X and Y, it's very popular, X and Y, things like that, right? Especially you've got a lot of different JavaScript. You might be reading different files. You might be using libraries. Some things can get messed up if everything's at the global scope, especially it's easy for these var variables, right? So, but the var is declared here, right? Or anywhere in the function is visible throughout the entire function, right? Okay. So this is just showing you here you've got a function, right? Here you've got a block, right? Here you got a block. Here's your function, okay? Here's global. So here you define, it's okay to global scope here, right? Store name. You know, this you definitely want to make sure you're probably doing something very unique, right? Just in case, especially like, you know, for the stuff we're doing, probably not so much, but it's possible you could be using some libraries and stuff, and you know, you could have a little overwrite, variable overwrite. It's possible. Okay, so here you're doing a const store name. The beauty of a const here, right, is once you set that variable, it's not going to change, right? It's a constant. So you don't have to worry about too much of that there, okay? So here you've got a function, right? And then in here, this function, you're defining a let, right? So this let is going to have function scope. So this let is going to be accessible anywhere, okay? Well, discount rate, right? So this is at the function scope, right? So this is available anywhere within this function. So here, right? Discount rate is right here. You defined it up here. It's available, okay? Because you defined this at the function scope, okay? Here, this is at block scope, only inside the if block. So since you defined it here, you cannot access it outside of this if block, right? So right here, if you tried to access it here, it's not accessible outside the if block, okay? And when I do a demo here, I'll show you, you know, it's a little bit different with a var, okay? And that's why can be an issue with using var. So this controls things, right? You define something here, you only can use it here, right? You can't use it outside here. So that's what it means by block scope. Even though you can still put this at a global scope, right? Right? Or you can get this at a function scope, right? So you got a let here at a function scope. You've got this at a block scope, but it's block scope by default, right? It's block scope. If you put this in a block, it's only accessible within that block, right? Obviously, if you define something at a function scope, right, then it's going to be available anywhere within the function. And in this case, right here, you're accessing it, right? You know, because even though you're in this block, right, you're inside the function since you gave it function scope. So I hope that makes sense. Please let me know. I will go into this a little bit more in the demo. So referencing a block scope variable outside the block where it was declared produces an error. Referencing a global variable name inside a function is fine, but declaring a new variable with the same name inside that function creates a separate local variable and only exists within that function. Okay. Okay. When to use local variables? Temporary values used only within one function. For loops and counters, usually you use things like a counter, you know, counting how many times you loop through something, or some kind of calculations, all right? So you want to kind of use that for local variables. Avoid naming conflicts across the program, right? Like I mentioned a couple times already, you know, you got to be careful, especially using different files, reading stuff in. It can become an issue. Okay. When to use a global scope? Constant shared across an entire program, right? So and there's no reason to put a constant really out there if, you know, you always think ahead of things, right? So where is this going to be used and things like that. So if it's, it's only going to be used in one function. Do you really need to have this all the way up at top? Maybe, but if you're going to be using it in multiple places, then yeah, obviously you want to have that to global, right? But use it sparingly. Too many globals make programs harder to debug and maintain. So, all right. Working with data types. A data type is a specific category of information. A data type is a specific category of information a variable holds, which determines how much memory is set aside to store it. JavaScript recognizes 5 primitive types, each which can hold only a single value at a time. So it's always remember, your memory's being held, right? So a lot of this stuff is the browser is kind of taking care of this, right, behind the scenes. When you create a variable, it's being assigned to a spot in memory, right? It's being assigned to a place in memory, right? So 5 different primitive types. You have a number, right? So any numeric value, including integers and decimals. JavaScript does not have separate types for integers versus floating points, etc., right? As it is for other programming languages, right? JavaScript's a little more not really meant for that, right? String is text data enclosed in quotation marks or backticks. Okay. A Boolean is a logical value, either true or false. Okay. Then also there's undefined, the automatic value of a variable that has been declared but not assigned a value yet. If you declare a variable without assigning it, by default it's going to be undefined, right? Null, a deliberate assignment indicating no value. Unlike undefined, this is set intentionally by the programmer. Okay. Undefined means a value was never assigned. Null means the value was intentionally cleared out or left empty, right? The distinction matters when checking for missed data. So let's talk about strongly typed versus loosely typed languages, right? So a strongly typed language, also called statically typed language, requires you to explicitly declare the data type of every variable, and that cannot change. Okay. So if you've already taken C#, you had to do that. A lot of these other programming languages, C++, Java, many others, are strongly typed, statically typed. You have to declare that type, and that's it. You can't change that type, right? If you say it's an int for an integer, and you can't change that later to a string. Well, JavaScript is called a loosely typed language, also called dynamically typed or duck typed. You never declare a type, right? And the interpreter assigns one automatically based on the value stored at any given moment. It's the kind of interpreter. We've already looked at variables where we didn't say what kind of variable it is, right? So you never declare a type. The interpreter assigns one automatically, right? The type of the single variable can change as the program runs. So here you got an example where you've got data of 42, right? So that's what you assign that. Later on, you can come back and that's basically a number, right? The interpreter is going to say, yep, that's a number. I know that's a number. So I'm going to reserve memory space for that number 42, right? Then the next line here, it's saying, let's take data and let's assign this to a string called 42 like that, okay? So now it's a string, right? So the interpreter is now going to create data for 42, right? It's going to override that 42, that number one, and it's going to store it like that, right? Now, obviously, if you've, already done other programming languages, you've already experienced other programming languages like C#, you can't do that. First you have to define this as whatever this is, an integer, right? Or whatever kind of number, right? An int. So then you can't come back and now change it. No, you can't do that, right? So that's the difference between that strongly statically typed and loose dynamically typed, right? So JavaScript's very loose. So that's another thing, JavaScript, you can kind of get away with a lot of things that you can't really get away with, right? There's good and bad in that, right? Okay, an integer. So an integer is a positive or negative whole numbers with no decimal portion. A floating point number includes a decimal portion or is written using exponential notation, right? Exponential notation, also called scientific notation, is a compact way to represent very large or small numbers. JavaScript writes it using a letter. Okay. So once you start doing enough JavaScript, you'll start getting some things where you'll start seeing some E things in there. Okay. So JavaScript writes it using the E letter to separate the base value from the power of 10. Right. There's a whole number, there's a decimal, there's a very small, there's a very large, right? JavaScript stores all numbers internally as binary floating point values, which can introduce tiny rounding errors in decimal arithmetic. For example, right, this is important, 0.01 plus 0.02 does not always equal 0.3, right? So you got to be very careful with JavaScript. JavaScript's really not even best for monetary calculations, right? For money, because there can be rounding issues. So for monetary calculation, round results to a fixed number or decimal places or work in whole cents rather than dollars to avoid these discrepancies. Now, financial applications, true financial stuff we do, probably not going to be a big deal, right? But if you're building a financial application that has to be right, banks, right? Different financial institutions, when those numbers have to be right? Or, and even just, an ordering thing, anything where, we're just doing some little examples here and there, but when you're really building something that it's important for something where you're going to be rounding some numbers and different things like that, right? There's going to be, you're doing some multiplying some numbers and things like that. You can come up with discrepancies, right? It doesn't round things correctly. So be very careful with that. Working with Boolean values. So a Boolean value is a logical value of true or false, written without quotation marks, right? A Boolean is not the same as the strings true or false. So yeah, a beginner mistake here is using quotes around true or false. If you put a quote, if you put true or false in quotes, right? It's not a Boolean anymore. It's a string. Not that you can't set it to true, but you're going to have to check it as a string too, right? The true way to be actually use a Boolean is true or false, just like that with no quotes. Working with strings. Text string can be an empty string or a zero length value or contain any number of characters. Strings can be enclosed in single quotes, double quotes, or since the introduction of template literals, okay? So in the ES6, later versions of JavaScript, been around for a while, you can use backtick characters, right? JavaScript offers 3 approaches for working with multi-line content, right? Concatenating fragments, right? So here, we've already looked at this using concatenation, right? Also, there is available using a backslash, right? And each line in a backslash, like that. Use a template literal backticks, right? Just recall that these are not single quotes. These are backticks. These are the ones, this is the one on the left of your number 1 on your keyboard, right? That backtick. Right below what's called that tilde, right? Tilde, backtick have that same, or use that same key, right? On the left of your number 1 on your keyboard. So temperate literals, well, the good thing about temperate literals, you can also embed expressions, right? You can uh, variables, and so forth, right? So template literals also support embedded expressions using the $, open and curly braces syntax, eliminating the need for string concatenation in many cases, right? So here you've got, once again, you're using backticks, right? Here you're using item name, price. So the reason you got $2 here is the first $sign is required for you use the embedded expression, right? This is going to give you this whole part right here is going to be converted to whatever value the price is. Then that very first $sign is going to be the $sign that's going to display, right? Okay, escape characters and sequences. An escape character tells the interpreter that the character immediately following it has a special meaning rather than a literal one. In JavaScript, the escape character is the backslash. Okay? The combination of the escape character and the character that follows it is called the escape sequence, right? So there's some cases that you'll want to do this. In this case, so if you want to escape a single quote, you use backslash single quote. Here for double quote, backslash double quote. If you want to escape a backslash, you do a backslash. A new line character, backslash n is for a new line character, right? And then also this is a tab. So backslash t is for tab. So without escaping, this quote would end the string early, right? So what you're doing here, this is where you can actually, what this is saying, remember I talked about it earlier, I talked about it in chapter 1, the last video. So if you've got multiple quotes in here, right? If you got multiple quotes in here, usually you just want one quote at the beginning and one at the end. If you have something in here, like let's pretend this backslash is not here. If you got this quote, it's going to terminate. Once you got a beginning, it's going to look for the first one that closes. Boom, it would terminate without this backslash. This backslash is saying, kind of ignore this. Just kind of tell them, ignore this kind of thing, right? So you can, without escaping, this quote would end the string early, right? It would do this, and then boom, you get a different result. But if you use the backslash, you can go ahead and use these double quotes, or same with the single quotes, right? This will go ahead and escape that, right? So this will escape that, so you can use it that way. Also, double backslash for a file path, right? If you just have a single one in there, there's certain ones that you have to make sure that you have to make sure that you escape certain ones, right? And one of them is the backslash. So you've got, whenever you have a backslash, you need to escape that backslash, right? For it to work correctly. Okay, let's look at using operators to build expressions. So binary versus unary operators, right? A binary operator requires one operand before it and one operand after it, such as an addition operator in A plus B. A unary operator requires only a single operand placed either before or after the operator. Okay, so let's look at some of these. So here's your arithmetic operators. Plus for addition, minus for subtraction, multiplication, asterisk, right? Division, forward slash, not backslash, forward slash. Modulus is the percent, right? And for exponents, right, the double asterisk, right? Division, forward slash, gives fractional result whenever the numbers do not divide evenly. The modulus operator percent instead returns only the leftover remainder, which is useful for tasks such as determining whether a number is odd or even. Yep. So that's for numbers, right? And then also rows when you're traversing a document. Traversing a document means kind of running through your HTML document, right? Your urinary operators, prefix versus postfix. Okay. So in this case, an increment plus plus and a decrement minus minus. Operators, right? Can add or subtract one from the variable, there, right? Their replacement changes the order of operation. A prefix operator placed before the variable, okay? So here's one before the variable. Updates the value first, then returns the new variable, the value, okay? So that's important. Places before. Updates the value first. So when you do this, right, you are updating a prefix. This is a prefix, right, before. So you're updating stock to whatever the value is. In this case, you start it with 5, right? You're updating this. Stock is now 6, right? And then you're returning that value, right? Prefix result is 6, right? Okay. In this case, postfix is 5. Count becomes 6 afterward. Okay? So what happens here is actually postfix will be 5. Okay? It's not going to be 6. Right? And count becomes 6 after this is finished. Once this finishes, boom. Once this happens, right, later, then it will go ahead and update count. Count will get updated after this has already been assigned, and it'll be assigned to a 5, right? Assignment operators, the equal sign assigns the value on its right to the variable on its left. Compound assignment operators combine assignments with a calculation in a single step. So we already kind of learned this one, plus equals, right? So x equals x plus y, right? That's equivalent to that, right? Or you can just say total plus or equals 10, right? Same thing. Minus equals, you can do x equals x minus y, or you can just take your variable and do a minus equal to that. So basically what that does real quick, as a review, it's going to basically say, take total, add 5, right? Whatever is in total, add 5 or subtract 5. I apologize in here. Be adding up here. And this one you're subtracting. Take the total, whatever the value is, subtract 5, and then put that value back in total, right? Same thing for multiplication, division, right? Modulus as well, right? And exponents as well, right? So here you got let cart total equal 25, cart total plus or equal 10. Now cart total is 35, right? Here's the plus equal operator, also concatenate strings, right? So then you can also do let message equal order number, right? And then so right now when you come down to this line, you've got order number has a value, right? Already has this value. Then you're going to go ahead and concatenate this, right? Well, basically, you're going to take this, add this, and then reassign the value into back here, right? A mathematical operation that cannot produce a valid numeric result, such as subtracting a non-numeric string from a number, returns not a number. Any further arithmetic performed using not a number value also returns not a number. So if you have, the value of something being, a color, red, and you try to add a number, right? or subtract a number, right? You can get away with concatenating, right? Concatenating with the plus sign, it's just going to treat that as a string. But if you try to like subtract or multiply, it's going to work because the interpreter is going to say that's not a number, right? I can't subtract that from that, right? So that's what happens there when you try to add a number, right? Add a non-number to a number, or subtract, not add, subtract it or multiply, divide it, right? When you do the add, it ends up being just concatenation, right? Okay, comparison operators. Comparison operators, also called relational operators, compare two operands and return a Boolean result. So here you've got equal to, this loose, right? This converts it, right? It does not use type conversion, right? So when you do the double equal sign, all right? Comparison, remember comparison operators are going to be either a double equal sign, right? For equals, or a triple equal sign, right? If you just using one equal sign, that means you're assigning a value, right? And I guarantee it's easy to make that mistake in your code when you start writing a lot of code, right? That's different, right? So double equal is a comparison operator. And in this case, this is doing with two equal signs, this is called doing what's called a loose does a loose conversion, right? So what this is going to do, it's going to take the number 5 and it's going to say, is this equal to string 5? And what happens to the interpreter under the hood is going to say, these are we're going to do a conversion on this. Can we make this the same? Kind of what it's going to do, right? Obviously, if the 5 here was a color, say red or something, right? That's not going to work, right? That's going to be false. But if the thing, if it's going to look at both and say, hey, can I convert this to something that makes sense here? And in this case, yes, it can. So it's going to say, is 5 equal to 5? Since you're doing two equal signs, this will turn true, right? Now, if you use the 3 equal signs, right, this is strict equality, right? No type conversion. So in this case, 5 with the triple equal sign, 5, this is going to be false. This says, don't do that. Don't do that little loose conversion, right? Not equal to loose, okay? Same thing here. So is 5 not equal to 6? That's true, right? It's not equal to true. It's actually using it, it's actually being able to, it's making a little right? It's making a little conversion to do this, right? Kind of like it's doing here, right? But it's also doing that here, right? It's kind of turning this into a 5 and a 6, right? And it's doing a little conversion, and then it's saying, yeah, nope, these aren't true, right? Now, if you do a strict not, so you're using two equal signs, the not sign plus two equal signs here, 5 is not equal to 5. That's true, right? Same thing here. So with this one, it's not going to convert that, right? It's not going to convert that with two equal signs. So it's going to be true. 5 is not equal. Yep, it's not equal to. Don't do this is saying don't do that conversion. Is the number 5 the same as the string 5? Right? If it's not, right, then say true. Okay, greater than, pretty much pretty common knowledge there. Greater than, less than. Is 9 greater than 4? True. Is 9 less than 4? False. Right? Greater than or equal to. Are greater than or less than. Less than or equal to. So when comparing two strings, JavaScript uses lexicographical order, right? Essentially, alphabetical order based on character codes, okay, rather than numeric order. So comparing a number directly to a string causes JavaScript to convert the string to a number first when possible. So a little tip here, using the triple equal sign or the not with the double equal sign in new code rather than the other ones, right? Basically doing the strict ones as opposed to the loose ones, right? The strict versions compare both values and type, avoiding surprising results from automatically typed conversion. Conditional ternary operator. The conditional operator, also called a ternary operator, since it requires three operands, okay, evaluates an expression and returns one or two possible values, depending on whether the expression is true or false. So here's the basic syntax where you've got a condition. It could be anything, x equals 5, whatever, right? Something that's going to evaluate to true or false, right? And then if it's true, it's going to use that, right? It's going to execute that. If it's false, it's going to execute that. All right, so here's an example. We've got an order total, setting that to 62. Then we've got our condition here, right? We're setting a variable, and we're setting that based on our this here. And then so we're basically saying our condition is order total greater than 50. Okay. If it is greater than 50, okay, use this one. If it's not, use this one. Okay. Falsy and truthy values. JavaScript treats every value as either a truthy or falsy when used in context expecting a Boolean. So for you who, did the C# course, this really doesn't, there's really not a falsy and truthy values. This is kind of one of those things in JavaScript, right? So basically, certain things are treated as either true or false. Basically, this have a value or is this not kind of a value, right? JavaScript treats every value as either a truthy or falsy when used in the context expecting a Boolean, such as an if condition. There are exactly 6 falsy values, okay? So this is basically an empty string, okay? This cannot be a space. This is not a space. This is an empty string. If you have a space in there, it's going to be a truthy value. This is a falsy value, right? There's no space here. A -1 is a falsy value. Or -1. -0, sorry. -0 is a falsy value. 0 is a falsy value, okay? Not a number is a falsy value. Null and undefined are also falsy values, right? Every other value, including non-empty strings, non-zero numbers, okay? So like a -2, right? That's considered truthy. That's a value. And all objects count as truthy value, any kind of object, okay? This allows for compact comparisons. So here's an example, just basically showing you. This is an empty string. There's nothing in here, right? There's no space or nothing, right? Compact falsy check, equivalent to if, okay. So instead of asking, hey, not equal to, you don't have to actually ask if it's not equal to. You can just say if coupon code, right? You don't necessarily have to test if this is empty, right? Or you don't have to check to say, hey, is this true, right? Just by default, every value, like it said, is either going to be truthy or falsy. So if every value is truthy or falsy, you can just drop it right in there. If coupon code, right, you don't care what's in here. So basically, if this has got something, right? If it's got something, if it's anything but these, if it's anything but these, this is going to execute. Otherwise, right? Well, let's see. Yeah, anything but these. So anything but these, this is going to execute. If coupon code contains any of these, evaluates to any of these, right? It's going to print that out. And in this case, it's just saying an empty one, right? But if you put a -1 in here, or a -0 in here, I'm stuck on that -1 stuff. Put a -0 or a 0 or NaN, right? You can't put that in a quote though. If you put NaN in a quote, it's got a value. You just have to put NaN by itself without the quotes, right? You put an NaN in here inside it, well, now it's got a value, right? It's not going to read it the same way, right? Same thing with any of these. You put any of these in a quote like this, right? It's a string now, right? It's a value, right? And we'll take a look at that in the demo a little bit as well. Logical operators. Logical operators combine multiple expressions into a single Boolean result or negate an existing Boolean value. Okay. So you got logical and, double, right? And then both expressions are true. Logical or, right here with the two, like the two pipes, right? That's a logical or. At least one expression is true. So basically, if you've got, so you're going to have, this is the operator. Whenever you've got an operator, you have operands, right? One on the left-hand side, one on the right-hand side, right? You're testing these. Both of these have to be true, right? If both of them are true, both expressions are true. If this returns true. If whatever's in here on both sides returns true, that means both expressions are true. Or, right, if you got one operator on this side, one on the other, if one or the other is true, okay, at least one expression is true, right? It's going to return true if one or the other. Here it's not, right? It reverses, right? So, if you got a not, you can just put the word true right here. If it's not true, right, logical and not true is false, right? So that's going to return either true or it's going to return the opposite of what's there, right? It's going to be the logical not. If the value is already true, it's going to flip it to false. If the value is already false, it's going to flip it to true. So it's going to reverse the Boolean value, okay? That's probably the best way to look at that. Sometimes you get really confused with the nots, not this, and oh my gosh, it can be kind of, it can kind of be confusing sometimes. So always think of it, the best way to think is just reversing whatever's there, right? Right? You just kind of hide that for a minute and say, okay, well, what's this returning? And then that not is just going to reverse whatever it is. And when I say reverse, there's only two options there. So you're going to be true or false. So if it's true, it's going to flip it to false. If it's false, it's going to flip it to true. Okay, so let's look at this one. We've got an age of 20. Has membership is true. Okay, so if the age is greater than or equal to 18, right? So that is true. And has membership. So remember, for the Boolean, you don't have to check to say you don't have to do equal true here, right? You don't have to check to see if this is true. You just drop it right in there, right? Well, this one's a Boolean, right? So that makes things easier. But this is already set to a Boolean true. You just drop it right in there. And then so basically this is going to return true and this is going to return true, right? Now I do want to mention this. Let's see, does it tell you that here? No. So I do want to mention this, that when you use like the double and, right, the logical and, so both of these have to be true. If this first one, just the way computers work, the way programming languages work here, it's going to check this first, okay? So we know, since we're using and, we know both of these have to be true. So first, just to be efficient for, efficiency for programming languages, it's going to check this first one, right? And for an and, if this is false, right? It's not even going to check this. It don't need to, because this has to be true for this to execute. If this is false, right? If this is false, then it knows it doesn't matter what this is. It's not going to execute this anyway, because both of these have to be true. So it doesn't even check this one right? If this one is already false. Special operators. Okay. JavaScript includes several operators that do not fit categories above. The most common used is type of, a unary operator that returns a string identifying the data type of its operand. So use the expression type of 42. If you do this in your code, it's going to return number. If you do type of a string, it's going to return string, right? Type of true, it's going to return Boolean. If you run a type of undefined, it's going to return undefined, right? And then here it's just telling you if you have an undeclared variable. So if you define, created a variable, but you didn't assign it a value, whatever variable that you would include on this, if you didn't assign it a value, it's going to return undefined, right? So here in this case, quantity of 12, since you defined it by using this, under the hood, the interpreter is going to say, oh, this is a number, and it's going to type of quantity, it's going to return a number. Now let's talk about understanding operator precedence. So operator precedence is a set of rules that determine the order in which operators within an operation are evaluated. Operators with higher precedence are evaluated before operators with lower precedence, regardless of their left to right position in the expression. Right? Associativity determines the order of evaluation when two or more operators in the same expression share equal precedence. Most operators are left to right associative, evaluated from left to right, while a small set, including the assignment operators, are right to left associative. Okay? So precedence overview here, highest to lowest. Parentheses have the highest, right? So unary, the double plus or the minus minus, right? Type of and not, right? Them are all from right to left. Now for exponentiation, right? The two asterisks, right? Right to left. Multiplication, division, and modulus is left to right. Addition and subtraction is left to right. Then comparison operators is left to right. Then your logical and, then your logical ors. Conditionals, then your conditional. And then your assignment operators, equal, plus equal, minus equal, etc. Right? So let's look at a little bit of this. Multiplication happens before addition. We're not going to be doing things too complicated here, but it's still important for you to know it. All right? And obviously in math, you probably have learned all of this, but sometimes it might be been a while, right? So multiplication happens before addition, regardless of the order written. So the total is 10, not 14. So 3 times 2 happens before 4 plus 3, right? So 3 times 2 is 6, right? Then 4 plus 6 equals 10, right? Parentheses overrides default precedence, right? So here you've got 4 plus 3. Obviously, multiplication, right? In this case, addition's not going to happen until you use multiplication first, right? You're going to multiply first, then you're going to add. In this case, since these are in parentheses, you're going to add 4 plus 3, which is 7, and you're going to multiply that by 2, which is 14. So here, you've got left to right associativity for equal precedence subtraction, right? 20 minus 5 minus 3, right? Basically is evaluated as you take 20 minus 5 first, right? 20 minus 5. which is 15, and then 15 minus 3 is 12. So right to left associativity for chained assignments. So here, you do this differently, right? So you got x, y, and z. X equals y equals z equals 5. This is evaluated as x equals, right? You're going to do the z equal 5, parentheses first, right? Then you're going to set y to whatever the value of this is, right? Which is 5, right? Then you evaluate the x, right? So when in doubt about an expression will be evaluated, add parentheses, right? So you can add the parentheses to help you figure it out, right? Using expressions within web form controls. Reading input control values. Every text-based form control stores its current content in a value property. A function can retrieve that value through document.getElement by ID and assign it to a variable for further use, such as a calculation. So in this case here, we've got an input type number, right? And it has an ID of low quantity. So here's a JavaScript read the controls value and convert it to a number. So here you're doing basically a document.getElement by ID of low quantity, right? And you're getting the element, right? That's the whole element. That's not necessarily the value. If you want the value, you got to do that value on it, right? You're just getting the whole object. We kind of looked at that a little bit in the developer tools, Chrome developer tools. It's basically a lot of other information there, right? If you want that value, you've got to, that's not going to return a value, just that element. You got to say, hey, give me the value of that, right? Give me a value of that HTML element. So that will give you the value of that. Then, right, so then whatever it is here is going to be a number. Now, obviously, if it cannot, if this returned a string, let's say the color red, R-E-D, number, trying to do a number on that's going to return NaN, not a number, right? For input values, form input values are always retrieved as strings. Okay, and I kind of mentioned that earlier. Even from numeric input control. So it is important to convert them with number or parse int or parse float before using them in arithmetic. Okay? So yeah, when you put things in, especially those form input, all those form input fields, them are all strings. It's only passing strings, right? You're going to use them. You need to convert those, right? And if for some reason a user put the wrong thing in there, that's when you kind of use validation. You're going to check them before you start doing things in it. You don't want to just have an error and, nope, it was an error. You got to let them know, hey, that was supposed to be a number. Please enter a valid number, right? So input values are always treated as strings, even from the numeric input control. So it's important to convert them to either a number, parse int, parse float, right, etc. All right, running total. So here's, you're defining a running total. Initialized before the calculation, you're setting it to 0, right? Here you can tell you're just adding it, right? So here your compound assignment updates the total. So you're just basically doing running total equals whatever's in running total, right? Plus, well, basically quantity, take whatever's in running total, all right? And then add quantity plus 6.5 and put that back in running total. Working with checkboxes. So checkboxes input stores as selected state in a Boolean. Check property, true if selected, false if not. So this Boolean value can drive a conditional operator to adjust another variable. So here you got a checkbox called GIF wrap, okay, with the ID of GIF wrap. You're getting that, and then you're checking is this checked, all right? So once again, you got a checkbox. This is not getting Just this by itself is not getting a value. It's not telling you if it's checked. Well, it'll give you that whole object of all kinds of things. But if you're wanting something specific, some certain attribute, you want to know, hey, is this checked? Do not checked on that, right? So then if this is checked, if this is true, right? If it's checked, this is going to be true. If it's not checked, it's going to be false. So if it's checked, then wrap fee is going to be 2.5, else it's going to be 0, right? Displaying results within our HTML. To display a calculated value on a page, target a container's element such as with the span tag and assign a new content to its inner HTML property. So here you've got a paragraph tag, right? And you've got a span tag here. And then what you're doing here is you're getting the element by ID, you're getting the order total, right? Dot inner HTML, that's basically getting this, right? So by default, it's going to be 0. When you do it like this and you set it to a value, it's going to replace this to whatever this evaluates to. Running total dot to fixed. This is just going to give you 2 decimal places, right? It's going to take the value and make it to 2 decimal places. Using chain event with form controls. The change event fires when a value from a form control is modified and the control then loses focus. Or for checkboxes and select list, immediately when the selection changes, all right? So yeah, for a checkbox, basically that's going to happen when you, so the change event happens when the form control is modified and the control then loses focus, yes. So yeah, so like if you're putting a value in a text box, right? The event's not going to change until you move out of that, okay? Until you lose focus from that, right? Because if you started typing, you wouldn't want it to like the first letter, right? You can do stuff, and later assignments will do a little bit of that with some keyboard stuff. But if you've got a form text box, once you hit one letter, you don't want it to change. You don't want that event to fire. You want to wait until you got everything put in that text box, right? And then you lose focus. You move focus away from that, right? By tabbing or clicking to the next thing. Then that change event will fire, right? But for checkboxes, right, which makes sense. Once you check a box, boom, you checked it, right? So it's going to fire right away. The same with a select list, right? You got to select. Once you choose one of the things from the select list, it's going to immediately fire as well, right? So attaching a recalculation function to this event keeps displayed totals current as the user interacts with the form. So this is showing you an example where you've got an input field of number, right? On change, you're going to recalculate total, right? So basically, like I said, when you lose focus, as an input type, let's just say a text one, well, it's a number, but still a text field on a HTML form, right? And basically, when you lose focus, you, like I said, either tab off or click onto the next thing. It's going to fire this on change event, right? Recalculate total, right? Here we added an event listener. We already kind of looked at event listeners, right? So here you got add event listener that you add to here. So just by defining this, you're good, right? You're defining this in your page. Well, here you can define this somewhere else in your page. This is going to, what's going to happen is, once again, kind of as a little bit of a review. So when you do an add event listener, it's going to basically say, get me the document, get element by ID, okay? Let's register an event listener, right? Let's register this. So basically, we want to register this so that for this element by ID, so this HTML element, we want to register a change event, right? And when that changes, we want to recalculate total, right? And once again, you don't want to do the open and close parentheses. I know it's easy to want to do that, right? So this is equivalent to this, right? This is equivalent to this. But this is always nice to be able to add these event listeners early on, right? A good way to do that. You kind of register all these events. And so in this case, you're registering this event for this. And so when this happens, you recalculate the total, right? All right. A typical form setup function attaches on change. Listeners, here, let me read this right. A typical form setup function attaches on change listeners to every relevant input when the page loads. So any field the user edits automatically triggers a fresh calculation. All right. Locating errors with the browser console. Okay, the browser console is a pain, right? We already looked at this into everything. Every modern browser has that. You're going to have to look. I tell you, really just earlier I was doing some stuff, and things do change. I don't like you cut and pasting stuff in there either anymore, because I guess people were doing that, and if you don't, not understanding what they were doing, right? So it's kind of preventing some of that. But a lot of this you can do, right? And you can actually do things in there that have nothing to do with the page. So right now, since I am on this page and I've high enough 12, right? It knows what's going on in this page, right? So you can actually add stuff that have nothing to do with this page whatsoever, right? So what was I doing here? What were we kind of redone our page here a little bit? Let me look at something here. Yeah. So here, just for fun here, let's see type of. So we can do type of. And let's just put a number here. 8. Enter. Boom. It'll tell you the number. Even though they had nothing to do with our page. It's actually, you can execute JavaScript in here. You can do anything you want in here. Why you would do that, not necessarily for any reason, but I'm just saying that you can. Right? And you're creating that, and then you could do a T++ here, right? Well, we learned that actually it does that differently, right? It's actually going to, if you do file, let's do plus T. Now it's 7. The reason it's 7, remember, and this is kind of a review, I did T plus 5, I did T plus increment at 1. But if we recall, T's value still is 5 if you do the post one, right? Until later on. So it actually gave us this, returned this. After it returned this, then it incremented this to 6. Then when I did this pre-increment, right? Pre-increment, it's already 6, but since you do a pre-increment, it's going to return 7, right? Hope that makes sense. We were kind of doing that earlier, right? But so right here, anything you've got, let's just make sure. Let's do a type of, and let me see if it's going to find this. I don't think it's going to find this. What, recalculate total? Undefined. That's because this is just kind of a guide, right? It's not really just showing this stuff. It's telling you. But this is how you can do things. So then anything defined in here, if you've got anything defined in here, any variables that are defined in here, this is just kind of a guide. This ain't really the demo. I'll show you this again in the demo. Makes more sense. But okay, let's see where we're at. So, but we will look at that some more. That's basically using our Chrome developer tools. So when the console reports an error, typically lists three pieces of useful information and description of the error type and cause, right? The file name where the problem occurred and the line number within the file. Common error messages include, right? Syntax error. So that's just basically you wrote your code wrong, malformed code, such as a missing closing brace or parentheses, right? A reference error is using a variable or a function name that has not been declared, right? Type error, attempting an operation that the data type does not support, such as calling dot value on an element reference that does not exist. A type error mentioning a null or missing property often means document by ID could not find an element with the ID, right? With that ID. Frequently because the script ran before the element existed on the page or because the ID was misspelled. Yep. So that's one of the first things you want to do if something's not working, okay? You can't see anything else. You're using Visual Studio Code. You don't really see anything that's wrong in there. Go and look at how things are spelled. And actually, the Visual Studio Code will catch if you're trying to use a variable that doesn't have that match. But, that's very common, being misspelled or not being there at all, right? Missing it completely. So open the console early and often during development. Yeah, get used to using that. It's a very, very handy tool to be able to use that and learn how to debug things. Will save you lots of time. So let's just go ahead and go through this real quick. A name function, that's where you start with the name. You use the function keyword itself, then the name and whatever parameters. This is the name that you give it, right? Parameters and your open and close curly braces and all your statements in between those curly braces. Anonymous function has no name, right? It's defined inline where it is needed. Calling versus defining, okay? Defining creates the function. A call with open and close parentheses executes it, right? Event listener. So here's an example where you do add event listener, right? And this is just showing you generic. You wouldn't use this. It'd be like change, right? And you don't put the on stuff. Change, mouse out, right? Mouse over, etc. Right? Event model phases, capture down, then bubbling back up. Block scope. We talked about block scope. You got let and you have const inside the curly braces are visible only there, right? They're block scoped only within those curly braces if you have it in the block, right? You define that at the top in a global file. Yes, it's going to be available anywhere, but by default, it's once you put that in the block scope, it's only available there, right? Now var or let const outside of an inner block visible throughout the function, right? Primitive types: number, string, boolean, undefined, null. Loosely typed: JavaScript assigns and changes types automatically, right? If it looks at something and says, can I convert this to that same type? If I can, then let's convert it and let's compare it, right? That's loosely typed. JavaScript, that's one thing about JavaScript. Different than the other programming languages, right? Other programmers not licensed. You got to tell it what kind of variable it is, right? You can't do that. You don't have that inner conversion going on like that, right? Template literal, that's where you use the backticks, right? You use the backticks with the $ open, with the curly braces, and you can put your expression variable right in there, right? Called interpolation. So that's the template literal, that the back tick. That's right on the key on the left-hand side of the number 1 key. Falsy values. So the different falsy values is either empty string, remember, and that's not a space, right? You put a space in there, space is going to be truthy. A -1, a 0, a not a number, a null, or undefined are all falsy. Everything else is true. Okay? Everything else, any other value is going to evaluate to true. Once again, though, realize that if you got a variable and you got NaN in quotes or null in quotes or undefined, any of these in quotes, right? If you have any of these in quotes, then they're going to be truthy then. They're not going to be falsy, right? Strict equality, using 3 equal signs, right? And the not, the exclamation point with the double equals, okay? Them are the strict equality. Avoid unwanted type conversion. You should always try to use those, right? You really don't want to do that. Let the interpreter go ahead and do that. You should, probably best for you to control that yourself, right? Conditional operator. That's where you have a condition, whatever that may be, x equals 5, right? And then you're passing in some value, you're testing it. Use the question mark. If the condition is true, then it's going to return that. Else, it's going to return that. Okay. Type of returns a string naming of a value's data type, right? So Boolean, not a number, all these different types of, right? String, etc. Right? Precedence versus associativity. Precedent orders different operators, right? Associativity orders equal ones. Browser console, basically, you can use the developer tools, right? Chrome developer tools, so gives you some information, right? Okay, so now let's go ahead and take a look at the demo. Okay, we're continuing with the Pixel Arcade. So this is over functions, data types, and operators. Okay, so let's go ahead and let me get this set up real quick here. Okay, so first one here is kind of a score calculator. You enter a raw score, choose a difficulty, and toggle the hardcore mode. Let's just go ahead and add 1500, right? And then we can calculate the final score. It's going to give you all of this. If you want to add hardcore, then you can calculate it. We'll change that, right? Then we got a drop down here as well, a select, right? So each of these are used in different ways here, right? So here, obviously your text fields, you're just adding values, right? So the text to raw score, right, is right here. Nothing's assigned to that. Doesn't change any values at that point. Well, it's going to set the value, right? It's basically when you click calculate the final score. So let's go look at that. Oh, should have known better. So here you're doing a calculate the final score, right? That's basically on click event of the calculate. You're getting your raw value, right? And so this is going to be your raw score input, which is basically this field, and you're getting the dot value. Remember, you always have to get what you're looking for. If it was a checkbox, you'd have to do that, right? So we're going to actually take a look at that because we'll eventually here we're going to have a checkbox. So that will get you the value. So whatever was entered in here, when you click this button, is going to be assigned based on this let, right? And here's your raw score. Okay, so you're taking that, And so that's a number, right? So you're going to parse that. You want to parse that to a number. But you're going to use it in any kind of calculation, right? So it's possible if you put in something other than a number that can be converted to a number, what's going to happen here, this would be actually not NaN, would be NaN. So this is testing that, okay? This is testing that. So first you get the raw value, right, by using dot value on that get element by ID, right? Then you're taking your variable, you define it as a let, type let, not type let, but a let, and then you're doing a parse int on that, right? So for you who've familiar with C#, things like this, and you kind of get an error trying to parse. You know, we did have some certain methods that we could use to prevent us from getting an error, right? But just the basic parsing, boom, you're going to get an error on that, right? Well, this is just going to set this, right, to not a number, right? And so we can actually go. Let me just do this real quick. We don't have a lot of room here. It's always hard to do this with. So we got that. Okay, we got that. That's still there. Good. All right. Yeah, sometimes it does some weird things here. I think it's because of the live server thing. Okay, so we're going to look at, what do we want to look at? We want to look at raw score. Come on. Help me out a little bit here. There we go. Raw score. So I'm typing this in now. Right? I got that. But what's going to happen right now? If I hit this, this isn't, we haven't clicked anything, right? It's only the scope of this is that it's within that function. So this got function scope, right? This isn't globally. So what's going to happen here? This should be undefined, right? There you go, right? All score is not defined. Uncaught reference error, right? Now, once I hit shouldn't say that. We'd have to do something different here. Because even if I do this, it's going to execute this. And once it does, it's not going to be there anyhow. Sorry, I'm thinking through this a little bit. Now, we used to be able to do this. I'm going to see if this is still going to work. Okay, debugger, just like that. I'm going to save that. Actually, let me just open live server again. Let me close that. And then I'm going to hit F12 here. So I want to put in some junk here. And then I'm going to see if it's going to stop here. Let's see what this does. So yes, I think we did do well. So if you kind of come up here, we're going to learn how to use this tool later. I'm just showing this is kind of one of the first introductions here, right? But so we came in here and I put some string text in there, right? Just some junk, some letters. So when it came in here, it would go ahead and parse this, right? Whatever's in here is going to parse it. Like I said, comparing this to other languages, usually with something like that would fail, right? But what it's going to do, it's just going to set this to not a number, right? So as you can see, you can come up here and just hover over this, and you can see it says NaN, not a number, right there. And this is a good tool to put in. You can stop things and look at values. There's my value I put in, right? Now here's my raw score, not a number, etc., right? And you can watch it kind of actually execute, okay? And actually, there's these things right here, right? To go to the next line. So is not a number, raw score, that's going to return true, right? Raw score is not a number. And it's going to go ahead and set raw score equal to this, right? Let's see what raw score equals, not a number. Yeah. And then we'll just go ahead and continue on. And we can see enter a numeric score first. You typed in that, right? So just kind of want to show you, well, a few things I kind of wanted to show you there. One, just introduce you a little bit to the using the debugger. We'll learn more about it. The better you get at it, the more it's going to help you to get through things. This is a very good tool to do that. Just put in a debugger like that, and we'll stop inside here at that breakpoint. It's not going to stop inside here, okay? I know, like in the C# course, when we Visual Studio 2026, you can actually, set some things. Not that there's not ways to do that in here, but this makes things, there's a little bit more involved. But this one, when you do that and you run it right here within the browser, it is going to stop at that point, right? And it's going to show you the code, and you can actually walk through your JavaScript right within the browser, okay? All right. Let's get rid of that. Let's make this a little smaller here. Okay. So we did the parse int. So it converts the text box string value to a whole number. Form values are always strings. Form values, remember that. Form values are always strings. Even from a number input, because you can define your input as being a number within the HTML, right? You can say, hey, this is a number, but no, it's not. It's still going to, when it converts that, when it uses that, when you submit things, it's going to be a string. So you have to do some kind of conversion, right? And in this case, we're parsing an int. We're not parsing a float. We're parsing an int. We expect this to be a whole number, kind of an integer, right? And then obviously, if I put in 1500.65 and hit calculate, so what that's going to do there, right? It still is fine, right? And that's what I expect, right? It's actually just going to, it's truncating. Even though you put in there, it's not using that, right? Because it's going to parse that to an int. All right. So let's see what else we want to look at here. And what this is doing is, so you have difficulty here, right? So then this one here, you're taking their difficulty value, right? And then in here, right, you've got these different ones, right? So let's go look at the HTML for that. So we'll have to go look at the HTML for that a little bit here. So that was that. That's our hardcore. Oh, our select statement. So here we've got these values, 1, 1.25. But once again, this value that's in here, these are all strings, right? Well, they're even quotes, right? So when you try to access these, right, you're going to have to convert this to a number if you're going to be using it, right? And in our cases, we're trying to use it, so we need to convert that to a number. All right, let me get down here, sorry. So here, we're getting that difficulty select, right? We get that select. So the select is going to be, once it's selected, it's going to be one of those values, right? So it's grabbing that value, and that's going to be that multiplier there, right? So we already seen the raw score. And then we're checking our is hardcore, right? So that is what? A checkbox. So we do dot checked. Is this dot checked? So this is either going to be a Boolean, true or false, right? This should be a value. And since we've got those values already in there, they should all be able to be converted, right, to a number, right? So now you got a number, whatever you put in there, right? Whichever one you choose, you got a number. And then you got your hardcore, 50% bonus. Then, so you're taking your hardcore bonus is hardcore. Oh, so basically, yeah, is hardcore is either going to be true or false, right? It's either checked or not checked. If it's checked, it's going to be 1.5, right? Our bonus is going to be 1.5. If it's not checked, right, it's going to be 1. So this is a ternary operator. That's what this is with the question mark, right? You pick a bonus rate based on the checkbox's Boolean value, right? If it's checked, it's true. Otherwise, it's 1. Multiplication happens before the variable is ever read again here. Yep. Yep. So you've got all of these in its own variable. Raw score, difficulty multiplier, and hardcore bonus. Add them all together, right? Total games played, you're incrementing this, right? So what's important here is this one, right? Well, not just this one, but if you're trying to track total games played, you have to track this outside of what? Outside of your function, right? Because once this function executes, boom, your variables are gone, right? Your variables are gone unless you've got it defined outside there. So let's see where total games played should be up here. Let's see where we define that at. Is it in our script here? Let me search for this real quick. So yeah, once again, up here, your body tag, you're defining a couple variables. You got a player name, right? Global variable, right? It's a const, right? Constant. Here you got the total games played, starting by default at 0. So as long as you don't refresh this page, right? Once you refresh this page, that's going to reset these. But as long as you don't refresh this page, it's going to continue to add to this every time you play another game, right? Every time you click that. So just games played, right? Each time. All right. Let's look at some functions here a little bit. Named versus anonymous. All right. Oh, I didn't mean to close that. All right. So here, you're kind of on a page load. This is add an event listener for on load once this whole page is loaded, right? Window.addLoad. This is in the script file. Basically, once that happens, it's going to go ahead and initialize the arcade, right? And so it's setting these variables here, right? Setting this, and then it's running a couple of other functions, right? Once this thing's done. This is common in JavaScript. You get everything loaded, then you might do some preliminary stuff to get some things going, right? In this case, you're setting up the mystery bonus button, you're set up the capture button, right? And so these are this is adding an event listener. Remember we talked about that already. Adding an event listener is basically you're registering, right? You're registering that this button, right? Registering an on-click event for this button, right? Mystery bonus button. Okay. Document element D. So this is just a setup, right? So this is just registering this, right? So once you register this, it's not like you come back and recreate it again, right? You don't rerun it. You basically, you kind of bind it, right? You bind it to your mystery bonus button. You bind that to this. This runs at the beginning, right? Then it kind of get executed when that time comes, okay? So let's just do this. Pixel received, double coins, right? Roll for a bonus item using a name function. You can see the call directly. All right, here's roll, mystery bonus unlocked, secret level key, right? So let's kind of look at that a little bit. So here's our name function, right? And some of this is maybe a little bit, some of this is a little farther along than where we're really at. But because, it's creating an array, right? So you got your bonus item, roll a bonus item, right? It's just randomly selecting these things. We'll learn this later in the future. But basically, it's using an array of things. So this is either like extra life or double coins, right? Or shield power up or speed boost. And it's just going to randomly select them. All right. This is show bonus result. And this has some special ones for that. All right. I don't want to get too far ahead. So, but run the function below to see which variables are visible where. So here's a variable scope. So section 3, run scope. So we're going to see what the scope of some of these variables are, right? And so the global scope, player name, right? So that was one that we kind of seen earlier. So the global scope player name equals pixel, visible everywhere. Function scope session multiplier starts at 1, right? So let's go look at those real quick. Let's see, right where we did our script. Player name, where's it at? So here's our global scope one. It's telling you this is a global scope, player name's global scope, right? So it's total, this is going to be global scope, right? It's defined up here at the top of your file, right? It's going to have access, these two variables, access anywhere. This one's going to be incremented, right? Depends on how many times you played it, right? Session multiplier. So let's see, that's function scope. Let's go find that one. So here's your run. Well, this is just, setting this right here equal to 1, right? So this is within that function. It's only going to be accessible through that by that function, right? Bonus round, block scope, right? Block scope bonus round. Right there. Only exists inside the if block, right here. So your scope is only within here, right? So this is showing you, you've got, well, you define your variables outside the block, right? These are defined at the function level, right? This one's defined at the block level. So you'll have access to these ones defined at the function level outside of your block here, right? So pretty straightforward there. All right, data types. So this is just telling you some different data types based on what this is just randomly creating some things. So high score is a string. Value true is a Boolean, right? It's just telling you this value itself, okay? Now, once again here, you're going to have to take, so when you're doing things like on a screen and stuff, you know, they're gonna be strings, right? So you have to actually do some conversions. But it's just telling you data types of the different ones, right? So null. So this one is an interesting one we need to talk a little bit about. So this is kind of a famous JavaScript quirk that a null is actually considered an object. A null, usually think of null as being nothing, right? But null in JavaScript is actually an object, okay? So null will return an object when you ask the type of null, right? Other things like, okay, that returned a number. That's a number. High score, that's just the name high score is a string, right? True returns a Boolean. Undefined returns an undefined, but null is that one that actually null is kind of an early setup with JavaScript that just never went away. That yes, type of null is an object, a famous JavaScript quirk. Okay. Truthy and falsy. Let's look at that a little bit here. And once again, when we're doing this stuff, it's going to have to convert these things, right? And actually, that's what it's doing. It's got all of these values, and it's basically saying if it's one of these, so if it's empty string, send this. If it's a 0, send this, okay? These are all drop downs. So if we look at this, right? If we look at this, what are we at? Number 5. So you're doing 0 here, right? You're kind of controlling this, right? If you just enter a value within a text field, it's always going to be a string unless you do a bunch of conversions here. So basically all you're saying is, right? So here's all your values, and you say if it's a 0, just return 0, right? And then when we return this thing, right? So then when we return this thing, what are we on, number 5 here? It's basically saying if this value comes in and it's a 0, set it to a 0, right? Or set it to a -1. That way you got all of these. So that way it'll correctly state what it is, okay? Where things like this come in much more detail is, when you're trying to do conversions from a text field and that, and or when you're kind of creating everything within the JavaScript itself, right? And you're doing a lot of computation of that. You want to make sure you have the right value, the right kinds, right? Or truth or falsy, right? So basically, an empty string is falsy, right? So that's that. Now, if I just put a space here, save this, and now that empty string, I actually put a thing in here. That's going to be truthy, right? I put this back, save, and select that again, and that's going to be falsy again, right? So 0, obviously 0 is going to be falsy. We went through all of these, right? 0 is going to be falsy. -1, not a number, null, undefined, right? False is going to be a number, right? So this is telling you like a string 0, like if you, and that's why I was saying anything in quotes like this, no matter what you put. So a 0, a false, right? A 0 or a false, what's going to happen on that? That's going to be truthy. That's a value. It's something, right? So different than a 0 here, right? And the same thing for the false thing here. Which one? Yep, string falsy. Is it the right one? Yeah. So that's going to be truthy as well because it's got a value in there. It has something, right? This, it's reading this as false, a actual Boolean, right? So that's going to be falsy. And then the number 42. So 42 is always going to be truthy. It's a value, right? All right. Let's see what happens on this. So 0, type of string. So pretty much anything that's a string, right? Anything you put in here, right? Since you're always dealing with strings, it's truthy, right? Even though you're seeing that, well, behind the scenes, putting those quotes in there, right? It's all passing that stuff, not putting quotes in there, it's passing them back and forth as strings, right? The only thing that's going to really work is making this an empty, putting nothing in here, and this would be falsy. There you go. Pretty much anything else, it doesn't matter because it's going to always wrap things in strings. Okay. So let's now compare. We're going to do that comparison there. And let's see, that's number 6. So basically, this one's just automatically got this all kind of hard-coded in here. So you got the number 5 being a 5 and the string 5 being 5 in quotes. Then obviously, we already know this. If you're doing 2 equal signs, it's going to convert that first, right? It's going to convert it first, right? If you're doing the strict kind, right, the strict kind, it's not going to convert it. So we're just going to click the button here, and it's basically telling you that 5 equals 5. Since you're doing the type conversion, right, then it's actually going to be true, right? It's automatically converted to compare it. When you use the triple equal signs, it's not going to convert it, and it's going to return false. Okay. And then here is an event model. Yeah. And you can kind of look at this yourself. This ain't a big deal. But click the button inside the nested boxes and watch how the order of events fire in the log below, right? So it depends on what you're doing, right? If you're clicking on this, press click, right? Capture outer cabinet, bubble outer cabinet, right? Let's clear the log. If we do the middle screen, right? It's because of how the event model happens, right? Right? The order of events fire, right, in a certain thing. So you did that. Now if I do the middle one, look how this is going to end up being. It's going to capture the outer cabinet, right? Then the middle screen, then the middle screen. It's going to do a capture of the outer screen. It's going to capture the middle screen. Then it's going to do a bubble of the middle screen, then a bubble of the outer cabinet. Okay. Then if I do and press the button here, it's going to do a lot more. It's going to capture the outer cabinet. It's going to capture the middle screen. It's going to capture the button. Right? Then it's going to bubble the button, bubble the middle screen, and then bubble the outer cabinet. So we'll talk about that more in the future. But that's all I have for today. Please let me know if you have any questions. I will make this demo available out there and send you a link to this. And so that's all I have, and have a great day. Thanks.